Hey everyone, thank you for joining us on today. We are excited to have you here for another community insightful session. Let me introduce today's speaker, Yash. Yash is a tech leader in InfoVision and also the community builder. He has extensive hands-on experience working with the cloud native architectures, containers, and DevOps workflow. Today he is going to talk to a very practical and highly in demand session from topic from Docker to AWS EC. If you have ever wonder how to take your local Docker setup to deploy them on the scalable production ready AWS infrastructure, session will clear everything for you. So ready to learn? Ask any question, take any notes. You can post your questions in the comments. With that, let's welcome Yash. Hand it to you. Hi Yash.
Hello. Hi. Hi, Pushkar. So, yeah, thanks for that nice introduction. Hi, guys. My name is Yash Garudkar. Today, we'll be looking at ECS and how we deploy containers with AWS. Just a minute. I'm just getting few messages actually over here, Pushkar. The team is saying a portrait version, not the landscape version on YouTube Live. Can you please check if there is some setting related
Okay,
to?
yeah. Yeah, updated. Yeah, they should able to see it.
Okay, just a minute. I'll just keep an eye.
Uh, there is some background noise.
From my end.
Yep.
Okay.
Yeah, no, fine.
Okay.
We have both versions live on the channel. So vertical is for shorts. So
Acha, okay, it gets deployed like that. Okay, is that so? Okay. Okay, yeah, perfect. This is working fine now. Okay, cool.
yeah,
So yeah, thanks for the introduction, Pushkar. I'm getting started now. Just a minute, I'll share my screen.
yeah, sure.
Okay, just a minute. Okay, cool. You can see
Yeah, yeah,
the slides, right?
yeah. It's visible.
Okay. Yeah, perfect. So today we are going to look at Docker with AWS ECS, which is relative to deploying the containers on AWS. So AWS is elastic containers, which basically means you can create your Dockerized applications and get them deployed on AWS. So, firstly, we're looking at the agenda today. I'm going to explain what is AWS ECS, Amazon ECS, what is the ECS architecture. We are going to look at two real world use cases. Then we'll be looking at a ECS deployment demo. The demo is not ready today, but we'll be looking at it on the next week, which is already scheduled. So please stay tuned for that. And then we'll be looking at ECS integration with other AWS services. We will be looking at the pros and cons of ECS, and we'll do a Q&A session. Yeah. So, what is AWS Amazon ECS? So, first of all, I'd like to take a step back here and explain what is Docker. So, Docker is a method, or you can say a service that allows you to create a container of your application. So for example, many of us has encountered in a situation, we have seen a situation where the environment that is where the application is running usually, which is the dev environment, let's say on my computer, it is not replicated when it gets deployed. That reason is because I'm using a different version of Mac server. The server which where it needs get to be deployed is different. My Postgres version is different. The deployed version is different. So to tackle these issues, what we do is we Dockerize the application. We tell Docker to pull these images from the cloud, where it gives us the exact correct version of, let's say, Node.js, Ubuntu Linux, or any other server that you would like. Let's say you want to use Postgres for a specific version. For example, I'm using Postgres version 17. It is going to take that and it will help you structure your application in such a way that every time the server is run through Docker, the environment for everything will be the same. The application will have the same environment as just as the other guy. So if someone on your team is facing an issue where, okay, I'm not able to run this because this is the version issue, all they have to do is install Docker on their machine and they get started with Docker. Now, what is Amazon ECS? ECS is basically Elastic Container Service, which is, it is a fully managed container orchestration service by AWS. Now, what does it mean to be fully managed? So, for example, usually what happens is, let's say for example, let's say databases, right? If I want to deploy my AWS Postgres database on AWS, I will go to RDS, but RDS is a fully managed container service. Fully managed database system by AWS, but the underlying servers are EC2 servers. So your database is basically running on an EC2 machine, but it is fully managed by AWS, and the wrapper itself is RDS, right? So similarly, you don't have to manage anything else. All you have to do is containerize your application and get it deployed on AWS. This is not going to just run your application on AWS. It will create a structure where you can easily scale down or scale up your containers. So we do not need to install Kubernetes to do this orchestration. That is a very good thing to go forward with when you start with containerization. It's a very simple way to get started with. Integrates natively with IAM, CloudWatch, uh, application load balancer, and ECR, which, so it has native support from AWS to integrate with these other services, which will help you get started with your application. Works with two launch type. One is EC2 launch type, you manage your instances, and second is Fargate launch type, which is AWS manages the compute. By the way, guys, we have a chat window open. Just a minute. Yeah, we have a chat window open. If anyone has any types of queries, please let me know. Pushkar and I are actively monitoring the chat on YouTube, so we'll be actively able to help you guys with understanding what's going on. Okay. So, have any queries, please do not hesitate. Go ahead and ask questions. Um, okay, back to our back to our presentation. So, what is the ECS architecture overview? What is, how does EC2 application is architected? How is ECS AWS architect? I'm sorry, I said EC2. So yeah, components. So one is cluster, group of container instances or Fargate tasks. So let's say, what is a container, right? So container is a singular application and which is Dockerized. Now, when these containers are running multiple, let's say five containers are running, I can create a cluster of containers. The why does this happen? So whenever there is a higher load on your application, let's say I have a Node.js API that is deployed, and the application is, let's say I have a e-commerce website and I have a sale going on. So as soon as that floodgates open, the sale has started, the containers will be hitting their capacity, right? So after that, it should automatically scale up or scale down. So that's how a cluster gets formed. You create clusters and you put your containers between it, and Amazon natively manages the scaling up and scaling down automatically. That can be configured. Next is the task definition. There is a JSON file that describes the containers. So it's pretty easy to get started with. JSON is, I think everyone understands JSON and are good with JSON here. Then there is service, which where you tell Amazon which services are required for your application and what desired number of tasks are there. Task is the running instance of the task definition. So basically, I've written a service and the task itself runs that service, right? So it's a running instance of the task definition. You have defined the task in your services, and now it will run. That is your task. Then there is load balancer. This is the routing that sends traffics to containers. So for example, if I'm saying key my containers is at a capacity of, let's say, 80%, 60%. Usually we go at 60 or 70%. So I need to balance that traffic out by running another container and send my traffic there. So that's what the load balancer does. It basically balances out your traffic and make sure all your containers are at their best capacity, handling the requests, handling the tasks, whichever it may be. Okay. So what is the use case one that we have for today? So web app deployment. This is a scenario where a Node.js web app is deployed with minimal operations. So the first thing I have here is the front end, which is in React S3 and CloudFront, which it is deployed to S3 bucket, and it is made like we are using the CDN service with CloudFront on AWS. If anyone would like to learn how React gets deployed to S3 and has a CloudFront service native, like out of the box, please check the link in description, or I think I have pasted a link in chat. Pushkar, can you please see if we can get that link in chat? Yeah. Okay. So okay, yeah. So what happens is in React, the application that you're looking in the GitHub comment that I have added. So I'll just quickly go over it and show you guys what it is about. This repository which says hello world Terraform is basically, it has this app and infra folder. It runs on Terraform. Sorry, not runs on Terraform. It is architected, or you can say the infrastructure that goes up on AWS is done with the help of Terraform. It's a actually very simple and very useful case to go with if you want to learn Terraform for your applications. This The app folder is basically the Next.js application. Like, it's on the latest version that's running. I just created it like a few, I think last week. I created it, and it's a very simple front end app. All I did was I submitted my resume content to V0. It created a page for me, and I put that page on Next.js. It's a very straightforward application. You can say I've written almost no code that is related to React.js. Mostly the code that I have written is inside the infra folder. Please go through it and take a look at how it can work for you. Okay. Then there is the next is Node.js, which is ECS Fargate, which let's say a containerized application of Node.js, which will get deployed through Fargate. The next is database, which is with Amazon RDS, and we have a load balancer with ALB, which is application load balancer. Yeah, so you can see all the parts of the application, front end, back end, database. These are the moving parts of the application, which is your actual application. Load balancer is something that is a wrapper on your application, which manages the load on your application. But you can see everything right now at this moment is deployed with AWS. What this does is it enables us to use other AWS services. Like, let's say I want to do with go forward and do an login system. So login system I can do with, let's say, AWS Cognito. So all these services, when everything gets deployed on AWS, it's pretty easy to manage these type of things, where you can integrate other AWS services with your application, which makes your application, like your deployment process and everything, very seamless. Yeah, moving to the deployment steps. So first thing what here needs to be done is building a Docker image and pushing it to ECR. Uh, and from there we create a task definition. We create a service in ECS, and we attach our application load balancer, which will take care of load balancing for our application, and it will automatically scale with CloudWatch. Auto scale with CloudWatch. So CloudWatch is a service where we look at if there are in whatever logging is there. It's a out of the box service, you can say, from AWS. So we can integrate that pretty much with everything. So this helps us when we deploy our applications to AWS. So that was our use case one. uh, I'm just checking on if we have any comments or any queries in our chat. Okay, yeah, I do have a few questions. Spinnaker supports ECS deployments, or if there are any other tools that help with continuous deployment to ECS, could you please share? Okay, I have not, Dinesh, I have not checked this. I will definitely go ahead and park that as a note for me. Dinesh Srinam, I'll get back you on this and answer that question. Okay, yeah. I think Abhishek has already replied to that question. So yeah, that goes correctly, because we are when we are deploying to ECS, it is pretty easier or very smooth if you go with GitHub or GitHub CI and CD with Amazon Code Deploy. It supports canary deployment, and it makes your deployments very easier because you have now CI/CD set up on your application on your GitHub. All you have to do is set it up once, and it gets deployed automatically. Okay, I'm going back to the presentation. I hope, Dinesh, your question was answered by Abhishek's reply over there. Yeah, okay, cool. Okay, so the use case two, event driven processing. So let's say we have IoT data streaming to ECS tasks. So one is SQS Kinesis. Processing is happening with Fargate tasks, and the storage we are using is S3 and DynamoDB. And the trigger is Event Bridge or Lambda. Lambda is basically serverless functions. I think everyone is aware of how serverless works, but simply it is a event driven architecture. So that is why we are using Lambda over here, which works as a trigger for our scenario. Okay, it has its own benefits. This use case has its own benefits, which is pay per tasks. Now, why pay per task? Why am I just paying for the task that is running? Because we are using serverless. That's a superpower that it gives us out of the box. So if I'm using a service, if it runs for a specific time, the function is running, I have to pay only for that much time, or that function over there. I don't have to pay the whole amount, which is, let's say I have a server which is running 24/7 for an indefinite period of time. This is much easier way to go. Then scale by queue depth. So for example, it will scale with how many functions, sorry, how many requests are being made, how deep your queue is, and it integrates easily with Event Bridge and SQS. Yeah, uh, excuse me. Okay, so these are the basic deployment commands, or you can say basic deployment steps for your deployment with using ECS. So what we do is, first you create your ECR repository, which is for deploying your containers, your container images. So you create your container image and you push it to the repository. Second is you prepare the networking, VPC, subnets, and the security group. You use Amazon's VPC service. In there we set up subnets, and then you create your security groups and use that for our deployment. All you have to do is set that up, select your preferences, and you select the VPC IDs and the security group ID and the subnet IDs, which while you're deploying the ECS cluster, ECS application, your container. Then you go ahead and you create a ECS cluster using Fargate. Then we define a task definition, which is container configuration, what type of CPU memory you would like, environment variables or secrets also. So this is relative to what kind of CPU memory we need for our container to run on. When the container runs, it is going to be running on a machine, right? Let's say a EC2 machine. When that EC2 machine is being set up, we need to configure what CPU it should have, what kind of memory it should have, like how many gigabits of storage it should run on. So this or RAM, sorry, RAM. When it will come to memory, it is about the RAM, and we need to set that up somewhere. So this is where you define the task for your ECS. Okay, then we create a service to run tasks, which is attaching to load balancer if it is at HTTP. So when we create a service, so we have written our task definition, right? So task definition is basically it takes my container config, it takes my CPU and memory configuration that I required, it takes my env variants and variables and secrets. Now this task definition is written. Now what I need to do is I need to create a service that runs these tasks. So when the task is run, my container config, the CPU memory, everything gets created in reality. So it is generated on AWS at this point when you create a service to run the tasks. Then we configure the auto scaling, which is optional, depending on your use case. Let's say I'm running a dev environment, I do not need auto scaling, but whenever we go into production, we need to make sure our application is scaling automatically, depending on the request, depending on the load that application is facing. Then we go to monitoring, testing, and iterating. So this is basically your agile methodology gets involved over here a little bit. So monitor is basically you can monitor what is going on with your ECS container using, let's say, CloudWatch. Then we test it out. You test your application out, and you reiterate whatever changes you need to make sure all your CI/CD needs are taken care of. Your deployments on your auto scaling is happening automatically. This is the agile methodology where it gets applied, and then we do the cleanup when we are done with it. So that's pretty much it for your deployment steps or deployment commands. Okay, so ECS integration with other services. So basically, when you come to Amazon, you are using ECS. Pretty much everything that is available on Amazon is your at your disposal. So you can use ECR, which stores your container images. So what is container image? For those who don't know what is a Docker container images, when you create a container on your Docker or on your local Docker setup, it actually creates a container image, right? That's what it is called, a container image. A small, imagine a small like a container. This uh, usually the thing that people do when it comes to containerization is imagine a huge ship, and it has lots of like these small container boxes that are getting shipped with it. You might have seen it in movies or somewhere, I don't know. But for example, it stores your container images. That image over there, it gets stored on your ECR. From there, we get deployed to ECS. So ECS is a service that runs that container. ECR is your repository where we store your container images. Then let's say for a very simple example I can give here is, you have written a microservice for your with your Node.js application or whatever you're using. You have created a container, and you have pushed that container as an image to the ECR, right? So whenever I want to deploy that microservice for a, let's say, enterprise level application, all I need to do is just make changes in my env variables and get that container image deployed. It gets shipped out of the box, and it's very easy to do also. That's one real nice, real good use case, I think it is, to explain this. And moving on to ALB and LLB. ALB is application load balancer and network load balancer. This is for manage like balancing out your ECS services. So load balancer basically takes care of your requests and make sure your computer, the compute system is not running at a very high limit of itself. Let's say it's at 60-70%. If it hits that percentage, it will go ahead and create another uh, container. It will run on the container in your cluster, and that it will balance out that request or the work task that it is taking care of. Just a minute, guys. Okay, I'm really sorry for that. I just got a call from my manager. Okay, so next we are going to look at CloudWatch, which is logs and metrics. It tells you whatever is going on with your application. If it is up, it is down, what kind of request it is handling, and the metrics that help you with scaling or scaling down your application. This is very crucial when we deploy to AWS and you are running on production. This is basically an eagle's eye view for your application, which tells you whatever is happening with your application, capacities, what metric it can be used, like what parameters are there. And based on that, you will get your metrics and you will get your responses from AWS, which tells you this is where your application is facing an issue, or this is where it is going good. That's why we use CloudWatch, which is a logging system mainly around AWS. IAM basically you use for your permissions, creating your roles and users and attaching them attaching user policies to them so they can do a specific set of tasks, and limit the usage around the limit those policies and limit those role permissions just as much as the user needs, or an account needs. S3 is something we use for file storage. You can deploy, you can upload your files to S3 and keep them accessible to other places. So you need to set up your S3 bucket. All you do is push your files and you use it as the file storage. It works really good as a host for static websites, that which is what we have done with the Hello World Terraform example that we looked at earlier. Then there is RDS and DynamoDB. DynamoDB is serviced by, it's a database serviced by AWS, which is like, it is proprietary service by AWS. So you need to go ahead and create a DynamoDB service and get it tested. I would really recommend you guys, if you want to use something that is no SQL, please go ahead and take a look at DynamoDB. Then then there is RDS, relational databases service. So it is I think everyone knows what is a relational database service. I'm not going to go deeper into that. Then Code Pipelines is a service by AWS, which is for your CI/CD tasks, continuous integration, continuous deployments. For example, if I need to have if I have a server and I'm pushing my code to my repository, I need something that runs the CI/CD pipeline. Let's say a YAML file that I've written my CI/CD structure in, my steps, the steps over there are overwritten. So first thing I'm going to do is install Node.js, then get my yarn dependency installed. Then using that yarn, I'm going to install my Node.js dependencies. And after everything is up and running, everything is available, I go ahead and start my Node.js server. So that is where code pipeline plays a crucial role. It helps you set up your CI/CD and it gets your deployments in structure. Next is Event Bridge and Lambda. Event Bridge and Lambda is basically triggers for your application. It takes care of event-driven services, event-driven architecture, or event-driven application that you have deployed. So Lambda is something which is a very famous, or very highly used service, I would say. Uh, yeah, it is famous, but it is famous for all the right reasons. I want to use Lambda for, let's say, I want to deploy, not deploy, I want to run a small service. So for example, I have a login management system, right? Authentication system. What I'm going to do is I'm going to get my Lambda function, a very small function which does a very small set of things. It is simply configurable. And when I deploy a serverless function to AWS, what it is going to do is it gives us the capability to pay only for what we are going to use. So because authentication service is a very core of any application, but it is very less used thing. When I log in into, let's say, AWS, uh, only once I'm going to log in. After that, everything is opened up for me for the next 24 hours or something. So Lambda plays a very crucial role when you are setting up a service, something like which is of small amount of time and a specific set of parameters, a specific set of things to do. Then we have a secrets manager for managing our credentials on AWS, and we have Cloud Map for services discovery. So all these services, the reason we are looking at today is they are easily integrate. They get easily integrated with ECS, or Elastic Container Service. Okay, yeah. Pros and cons. So what are the pros of our ECS deployment? So it enables us to do a deep AWS integration. What does it mean by doing a AWS, like a deep AWS integration? When all your services are communicating, the application is communicating with other AWS services and making use of that, and it is getting deployed. It's a very tightly coupled application with AWS, and I think that is a pro for the application, because now everything runs on AWS. It becomes easier for my team to take care of the deployments, take care of the finance side of things, which is making sure our costs are as we need to be. It doesn't go way off our budgets. So everything is, when everything is on AWS, it becomes difficult. It becomes easier for me to manage other services and making sure our application is getting shipped perfectly. There is no Kubernetes complexity when you are deploying with ECS, because It takes care of your scaling up and scaling down automatically using load balancers. Then when you are using Fargate, you don't have any service to take care of. All you do is deploy with Fargate. The next thing is it is cost efficient. So when you compare ECS and deploying something with natively, I would say EC2 is the simplest and example. So I get my EC2 server and I get my deployments set up over there. It's a very high cost setup, so I do not need to do that. When it comes to ECS, AWS takes care of that automatically. It's very cost efficient in that manner, and it gives us a native CI/CD platform which we can use out of the box. Nothing else need to be set up, and you can deploy your application. The cons, I would say, is AWS only. When you are deploying to ECS, of course, it's a AWS managed service, so it is always going to be on AWS. You cannot deploy it on anywhere else. It is less flexible than Kubernetes because Kubernetes has its own set of functions that it can do. Kubernetes itself, it is less flexible than Kubernetes. uh, AWS manages your load balancing. When you are working with Kubernetes, it's an orchestration platform of itself, so of course it is going to have some more set of functions or set of parameters that can be set, and that helps us scale easily and more flexibly. The networking is little complex when it comes to ECS, because it's a at a certain level it is manual setup that needs to be done, and we have to scale manually for the EC2 type deployments. Now let's take a look at these three services, and what is the difference between them. So ECS, EKS, and Lambda. ECS is the container elastic container service. Similarly, EKS relates to Kubernetes. Then there is, and finally there is Lambda, which is serverless, your serverless functions. So at management level, ECS is managed completely by AWS. When we look at EKS, Kubernetes service, it is partially managed by you and partially by AWS. And Lambda is fully managed by you. You have to write your own function, and it gets completely managed by AWS, right? Scaling, ECS can be automatically and manually scaled, because you can write a specific set of parameters that you need to scale your application within or without, and it gets deployed. EKS is automatic, and Lambda, again, it's automatic. It's completely scaled by AWS itself. The idea for ACS is for long running applications. If I have something that is continuously running for a longer period of time, that is when you turn towards ECS. EKS is for complex microservices. So you have like small containers which are scaled by EKS, and you have some complex data that is your microservices. That is when you should turn towards EKS. And when you need something that is event driven and is going to run for a small period of time, and it just needs to do a specific set of tasks, then that is when you turn towards Lambda, which is event driven service. You just call the function, it runs your task, and it gives an output. And the cost for ECS is pretty low, as we can see. EKS is a higher cost product, and Lambda is a paper execution product that I already explained. I'm just going back to YouTube, so I just need to see if there are any queries over here. Okay, perfect, perfect. I hope you guys are understanding. If there is anything that you are not understanding, anything that you would like to reach out about, please go ahead and ask your question in chat. Uh, Pushkar is here. I am here. And other friends from our other guys from our AWS user group, the community members over here are there. And yeah, and congrats to the team. I have a good count today. 45 people are watching us live on YouTube. So yeah, that's a good thing. Thank you guys. Okay, going back to our presentation. I think we are towards the end of our session today. But yeah, I do have a couple of slides to go with. Key takeaways from today's session is ECS simplifies your container orchestration with AWS native tools. So what it means basically is all you have to do is containerize your application, and the orchestration part is done with AWS native tools. What are these AWS native tools? Let's say ALB, NLB. These are native to AWS. And when the orchestration needs to happen, we need to tell AWS a specific set of rules that it will fall within, and the AWS setup, that ALB, NLB, it will take care of your container orchestration automatically. It will just look at what is the capacity that it is, the container is running at, and AWS will go ahead and scale up or scale down your ECS containers. Next is a Fargate for serverless EC2 control. So you can use AWS Fargate for controlling your EC2 and serverless use on AWS. It integrates easily with CI/CD, ALB, and CloudWatch. I think I already explained this, so I don't need to get any deeper into that. But you guys know what CI/CD is. We are looking at AWS. ALB is your application load balancer, and CloudWatch is something that helps you with the logs and metrics for your application. So ECS easily integrates with these services. Like CloudWatch and ALB, and you are able to look at our application with a eagle's perspective, eagle point of view, bird's eye view, you can say. Next is the ideal net next is it is ideal for web apps and data pipelines. So why is it ideal for web apps and data pipelines? Because these are variable variable functions, or variable, you can say, services, or deployments, not deployments, but variable products that you will build. So for example, if I'm building a web app product which runs on Node.js backend, or let's say Python backend, or any other backend, so I need to make sure my container scales up and scale down. So that's why it is ideal for that scenario. Then data pipelines also run for a specific period of time, right? So that is where it is ideal. That's where it should be very helpful for you guys, for your applications, of course. Yeah. So yeah, that was the last slide for today. If anyone from you wants to learn about ECS, please go to this URL, which is ecsworkshop.com. You can take a screenshot right now of this video, and you can refer to it later on. It's a very good site. I have gone through it, and it is very easier to learn ECS from there. Please go ahead and take a look at it. I'll definitely tell you that I can definitely say it is a very good uh, resource to learn from. The next best and always best resource to learn AWS products is AWS documentation. AWS docs.aws.com/ECS, which is basically going to take you to ECS documentation for AWS. And the GitHub example repo, add this Node.js app link. This is something I will go ahead and park for later. As I told you guys, the demo part I'm going to do in the next session. But yeah, you will have the Node.js application link for GitHub very soon. Yeah, thank you guys. That's all for today from my end. Just a minute. Yeah. Pushkar, are you there? Okay, I have a question from Dinesh Sriram. I'm seeing here.
Okay, sorry, I was speaking on mute.
Yeah, okay. Just 1 minute. I'll just answer this question from Dinesh. So Dinesh, when we are looking at standard CI/CD systems that to use with ECS, I already said that you can use AWS code pipeline, and you can also use GitHub CI/CD, which will help you with the deployment with ECS. Standardized way, I would say, is GitHub CI/CD, and I think GitLab also has this setup for making your CI/CD applications easy to set up with. So you can use this and go ahead with that. Okay. Yeah, code deploy with CD. Yeah, you're correct over there. So similarly, there is code pipeline. There is another service by AWS. You can take a look at that also. I hope that answers your question. Yes, Pushkar.
Yeah. Thank you so much, Yash, for like a informative session. That we really appreciate you breaking down the deployment with AWS ECS and explaining, like comparing the different services so our
Yeah.
users can choose from them. And we hope you learn something valuable, everyone. So, and you can confidently take your Docker containers to AWS right away. And if you have any remaining questions, you can always drop in a chat or reach out to us. And Please don't forget to follow our community for upcoming events and workshop and hands-on. I will be adding the meetup link in the chat so you can directly visit. So you can also follow us on the LinkedIn so you will get latest update right away to you. And yeah, once again, thank you for being there. Have a great day.
Great. Perfect. Perfect. So yeah, thanks Pushpa for having me for today's session. I'm really glad to be here, and I'm very happy to announce that I was just looking at the YouTube live link. I just looked at it right now. We have 50 people watching live on YouTube. I think that's a nice benchmark that we have for AWS Nashik now.
Yeah,
Mhm.
let's
Cool.
let's hope
Uh,
it's keep increasing in the next session. Yeah,
yeah, yeah, yeah. Great. So yeah, thank you again for having me. Thank you guys for joining us, and thank you Pushkar for hosting this session. Really looking forward to our next session very soon.
yeah. Bye bye, guys.
Yeah, cool. Bye. Thank you.